So that same formula, you could see it here. Now, I is not going to be the same as the rate all the time because I is defined as this, the rate divided by the number of compounding periods, and that is what M represents. So just like we used in section 5.2, if the number of compounding periods is monthly, then we will use M equals 12. If it was to be daily, we will use M equals 365. And here we have N, which will be the total number of compounding periods, and N is defined as M times T, the number of compounding periods multiplied by the number of years. So now we're going to move on to our second problem here. And we have a money market account, and we have a football player who just signed his first contract, and this is a 7-year contract. To prepare for his future, he wants to deposit this much at the end of each of the 7 years. And an account that will be paying 4.1% compounded annually. So again, for this one, we're going to use M is equal to 1. T will be 7 for 7 years. And we're going to have R is equal to 0.041. And we are going to have the payment, remember that is what PMT stands for, of $350,000. At the end of every year. So now we're going to use our formula, the one that we have here. So future value will equal the payment bracket. And then we have 1 plus I raised to the power n minus 1. And then I on the bottom. So let's see what we can substitute here. So the payment will be substituted with the 350,000. Then we're going to have our brackets here. And we're going to have to use an extra parentheses when we enter this on our calculator. So for the 1 plus, here it's important to mention that I is equal to R over M. So in this case, it will be R 0.041 divided by 1. So whenever the number of compounding periods is 1, then the R and I are equal to each other because we're just dividing by 1. So in this case, we will use 0.041. We have to close that parentheses and then the exponent, which will be n, and is defined as m times t. So n will be 1 times 7. So n is 7. Then we have to put a minus 1 but not inside the exponent, and then finally this will be divided by 0.041. Now the brackets will also have to be entered as parentheses. But if you have that fraction tool, the one that you have on MyMathLab, that you can use that, make sure you take advantage of it. So on your calculator, you will enter this as follows: 350,000, triple parentheses, 1 is for the bracket, 1 is for the numerator, and 1 is for the 1 plus 0.4.1. Close that parentheses, exponent 7, then move to the right side, or make sure you're not in the typing inside the exponent anymore. Then you enter minus 1. Then you have to close the numerator, and then you will enter the division, symbol, and then you could just enter 0.041 by itself, but then you have to close the parentheses one more time, and this will actually be the one closing the bracket. So if you enter all of that, and remember we're looking for the future value, so the future value of that after 7 years will be 2,772,807 with 59 cents. That would be the answer. Now for example 3, we're also going to have an ordinary annuity because the payments are also made at the end of but in this case it will be at the end of the month. So the problem says Allison opens a money market account at Silvergate Bank that in July 2016 offered a rate of 1.11. So let's convert that to a decimal, so 0.0111. Allison contributes $950, so that will be the payment a month to the account, and that the interest rate stays at the 1.11% compounded monthly, so M is going to be 12 for monthly for the next 10 years, so T is equal to 10. So from here, let's go ahead and find what would I equal to. So I is equal to R over M, and so that would be 0.0111 divided by 12. We're going to use that. We're not going to divide it. We're just going to use it like that as a fraction. And when we enter that on the calculator, we're just going to make sure to have parentheses around it. Let's also figure out what N will be. N is M times T. So 12 for monthly multiplied by 10 years. So that will give us a total of 120 periods or 120 payments. So now we want to know the value of the account after 10 years. So of course we're going to use T equals 10. And we're going to be using the same formula for the future value, and that says payment, bracket, parentheses 1 plus I to the power N minus 1 over I. Now, this formula could also be interpreted as the payment multiplied by 1 plus R over M, because that is equal to I. Instead of N, I'm going to write M times T, and then minus 1. Then I'm going to close my bracket and divide it by R over M. So now I'm going to start my substitution, so I'm going to have to make some room here. For the payment, we have 950. Then here we're going to have parentheses to enclose our numerator. And we need another one to enter our 1 plus. And here another time, another parentheses that will go here across our rate. So 0.0111 divided by 12, that's the M. Close that parentheses, but then this is what gets a lot of people. You have to close it again because this whole thing is being raised to the power N, or M times T, I should say. So it's like we're using this one to close this one. So imagine it's here and here. And then, of course, we will use the exponent, and in this case, we agree that was 12 times 10, so we could just put 120. And then you have to make sure that when you enter this on your calculator, you're not typing by the exponent anymore. And you move out of the exponent, you type in the 1, and then you close that parentheses to enclose your numerator. Then we're going to divide by R over M. and so that will be 0.0111 divided by 12. It will be safe if you put an extra set of parentheses here. And then at the end, of course, you have to close with a bracket like that. Now, what we could do there, when you enter your sets of parentheses, that will be the last one. So to enter this on your calculator, let's practice. So it will be 950, and then a triple parentheses, 1, 2, 3. The first one is the bracket. The second one is the one to enclose the numerator. And then the next one here is the one that we have with the 1 plus I, or 1 plus R over M. So in this case, we will have 1 plus 0.0111 divided by 12, close that parentheses. Then we will have, close that, and that will be raised to the power 120, or you could have done here 12 times 10. And then you must get out of the exponent to enter the -1. Then we close that to enclose the numerator. And then we will enter the division symbol. And then here in parentheses as well, we will enter the rate 0.0111 divided by 12 for monthly. Close the parentheses there, and then we close one more time to enclose the bracket. Why do we need brackets? Well, because this whole quantity is multiplying to the 950 for the payment. And so after entering all of that correctly on your calculator, you should get approximately 120,508 with 87 cents. We're going to round to the nearest 100 because we're talking about money. And so there is the answer. Now for part B of this same problem, we have, suppose that after 10 years, Allison was able to invest that much of the money, and now this one is being invested at a different interest rate, and for 10 years, after the 10 years, so the interest rate is 1.24%. So now we're going to use R equals 0.0124. M will also be equal to 12. But now this investment is only going to be there for 5 years. So our T is going to change to 5. So the question is, how much will be there, the total after the additional 5 years? So then we're going to calculate the future value, but now the payment, she would deposit the same, 950, will be 950 times 1 plus, the rate will change from 0.0124, 12 is the same, close that, and then that raised to the power of M times T, so that will be 12 times 5, so in this case we need 60 for our exponent, the one that will go right here, 60. Minus 1, we close that parentheses, that will be the numerator right here. Then we divide that by 0.0124 divided by 12, close it, and then we close one more time for the bracket, and so that will give